Hi, another teardown today. This time it's a bit of consumer tech. This is the Nike Plus Fuelband. Basically it's an accelerometer in a wristband that the idea is it keeps track of how much exercise you do, tell you how many calories you burnt off, all that sort of stuff. But I mean, exercise isn't something I do a great deal of, so I'm much more interested in what's inside this thing than what it actually does. Thanks to Daniel for donating this, and apparently he's quite happy for me to rip it to pieces, so let's go. Comes in this quite fancy box. There's a few little accessories. There's a desk stand, and there's also some extensions so you can adjust the size of the band. There's a little tool here. All it is basically is a pin that lets you remove and replace sections of the band. There's some little holes in the back. You just stick the tool in there and you can take the bits of the band off, and then you can add and remove different sections to get it to the right size to match the size of your wrist. I think the thing actually comes in 3 different sizes as well. I think it's the large one, so you can take that off and click that in, and then the whole thing ends up smaller. And on this end there's a USB connector. This is for charging. Not sure whether it's for downloading as well. I think it's mostly just for charging though, and it comes with a little extension lead, so of course you could plug that into a laptop, but with a desktop you'd have to bend it quite a long way to fit it. It's got this nice white matrix display on the front, and also this bar graph. I think the idea is that you set the amount of exercise you want to do throughout a day, your day, and this sort of gradually increases to show how far through that target you are. This one's got some weird firmware or something, so it just sticks in this mode. It doesn't actually seem to work, and the Nike site's not up at the moment, so I can't try updating it, but we'll maybe try that after I've taken it apart. So it's covered in this sort of rubbery coating. There's a couple of screw down panels here. There's a label which I've had off. There's nothing really behind that. They haven't hidden any screws. I think these are just moulding points, and that looks like it's something, but it actually just seems to be just a hole. Doesn't seem to have any obvious purpose. And there's another screw panel here, and then there's a USB connector on this side. And there's a battery in here. This looks like a fairly standard lithium polymer, but it's actually curved. It needs to be manufactured to fit the curve of the handle. This section is actually fairly rigid of the band. Although there's an overall rubber section. This is quite a rigid piece on the side. Then it gets bendy here. Then it's more rigid, sort of a bit more rigid in the centre. So it's not completely flexible. It's sort of flexible and rigid. Obviously you don't really want to be bending lithium polymer batteries that are strapped to your hand. Could get a little bit nasty if they decided to spontaneously combust if you bend them. And there's a second battery on the other one. Obviously this LED display is going to be taking quite a lot of power, so pretty much all the available space is taken up with battery. It looks like these batteries have been soldered in here, presumably with the battery at an angle, and then sort of folded down, so they seem to be slightly glued. Let's see if I can get it out. There we go. So there's nothing much in there, that's just part of the hard plastic moulding. Again, same on this side, nothing obvious under there, just the connections. One battery out and it's still running. And it died, obviously. And these look like fairly standard lithium polymer batteries. They've sort of folded the edges over, 36 milliamp hours each. Right, I can't see any way that this rubber is going to come off. I think it looks to me like this has actually been moulded in place, so they actually put the whole assembly inside and then injection mould this rubber, because there doesn't seem to be any holes big enough to actually get the insides out. It's not like a sleeve that clips over, I don't think. It seems to be very tightly attached around these battery doors. And certainly this white is there's like a sealing O-ring to seal the battery compartment, but the rubber does actually seem to be quite tightly moulded around everything, so I think it's going to have to be surgery time. I was sort of expecting to be able to sort of just slit this and sort of it peel off, but it does seem to be attached very well to the plastic. I think this could be a bit of an effort. Right, after an awful lot of peeling, just decided to sort of trim the edge off. I'm just starting to see some signs of some components in here. Just trying to peel as much as possible rather than cutting to avoid the risk of damaging the... I'm sure there's a flex PCB in here which will be very vulnerable to getting a knife through it. I got about half of it off and still working. The one lead I've managed to chip off, but seems to be getting there. So it looks like the overall construction is sort of various pieces of plastic frame, and then the whole thing's been injection moulded with this silicone rubber stuff. Fortunately it will just about peel off the surface of the PCB, but we've managed to get all the electronics exposed and it's still working. This flex PCB has got some insanely small tracks on it. There's obviously a lot of wires going to this LED display. Just in the process of trying to get the board out of the frame, got a bit of a surprise. These rigid parts around the battery are actually made of metal and not plastic. I presume that's just for maximum rigidity, to avoid any risk of nasty things happening if these batteries are flexed. And again, these battery covers, these are actually made of metal. I'm not quite sure which metal. Feels a bit harder than aluminium. I don't know, maybe it's magnesium or something. And this flex PCB seems to be stuck down to the back using sort of the thin film double-sided sticky type material. And in the past I found the way to separate this is just to do it very slowly, just apply a little bit of pressure and just let it peel by itself. So if it doesn't come immediately, don't press harder, just give it a little bit of time, and it does actually peel off without planning to apply too much force. Obviously the risk here is gouging out the back of the PCB and fracturing things, but if you just put a sort of blade type tool in there and just give the adhesive enough time just to separate by itself, it does actually come out without too much stress. So you can use a knife blade to part it, but you've got to be extremely careful that you don't chop into the PCB. You probably want a slightly blunt blade to do this. Just make sure the blade is kept along the plane of the surface so you don't cut into the PCB. A little bit of solvent can sometimes help. Just dribble a little bit of flux cleaning solvent in here. Just try and soften that adhesive a little bit. Yeah, actually that's helping a lot. That's really softening it very effectively. Well, that was an awful lot of work, but we've managed to extract the PCB out of it, and it's still working. And it's a series of flex rigid arrangements. You've got this flex, basically the flex is laminated into a PCB. I think this is actually probably all just a flex with some stiffening parts on it. The parts with components are slightly more rigid, but not really all that much more rigid than the rest. I think there's some extra layers, whether those are actually extra copper layers or whether they're just extra plastic layers to stiffen it up, I'm not sure. And you can see there's a few of these, quite a few test points dotted around. There's nothing on that side. Flexes like this will probably be assembled on a flat board, so all the assembly will be done rigid, then they'll be detached from the that board. I think they also sometimes use vacuum fixtures, so they actually use a bed that actually sucks the board down onto it to keep the whole thing flat for all the various assembly processes, the pick and place and the screen printing and then the solder reflow, and then they'll be detached out somehow. Right, let's take a close look at this board. Starting at this end, you've got the two battery terminals here. Next to it is this large Spansion serial flash device, FL032, it's pretty 32 megabit flash. This almost certainly is going to be for data logging, so you can actually monitor the activity and record it over a period of time and then download it afterwards. What we have here, I think this is the accelerometer. The marking suggests it's SGS Thompson Liz 3DH accelerometer, which is the one that's used in all the Apple gear. It's a 3-axis MEMS accelerometer. A few other chips here, not really clear what they are. Notice there's this gunge around them. These are probably BGA chips, and this is an underfill, probably just to stop the moulding compound getting under there. But also just to prevent them detaching from the board, so it's just a bit of extra help to stop the small ball contacts detaching. It's not uncommon to see that on BGAs. Some more chips here. What we've got here, this looks like the Bluetooth section. This chip at the bottom is a Texas Instruments CC2560, which is a 2.5 GHz transceiver, and that's next to an MSP430. It's an M430 FS 528 device, so this will be effectively a complete Bluetooth solution. There's a couple of crystals. Obviously this one here will be for the Bluetooth frequency reference, and there's one here for the MSP430. And it looks like the antenna, yeah, it looks like they've actually made the antenna on the PCB, so there's a little filter here, so a few more test points here, and there's actually this shaped bit of foil which is the Bluetooth antenna. As you can see, the tracks on this flex are extremely small. As we move across, this looks like an ambient light sensor. This one's I think it's got some firmware issues, and the ambient light sensor didn't seem to make a difference to the display. But obviously, with a LED display, if you're using it at night, you want to cut down the brightness so it's not obvious, but also to save battery power. Here we've got the array of white LEDs. Managed to lose one of them in the teardown process. Don't think I'll bother trying to reattach that one. And you've got the green, yellow, red ones down here on another little bit of flex. I think Pliny Large, I'm guessing Pliny is probably some internal code name, sort of project name. Quite often when when these things get designed, the marketing people haven't thought up what name they're going to call it, so it's not uncommon to have code names. And this is available in 3 different sizes, so I think there's actually different flex versions for the different size wristbands. I think that basically these sections here I've just made different lengths for the different sections. There's some photos in an FCC approval document that actually show all 3 versions. You can see this. Right, as we move up here, this is just the push button, the single button that's on it. It's a little clicky button. There's a ridiculously small little diode down here, and another bit of flex. This looks like the LED driver just because of the position and where it is, and this actually looks like a custom device. You can see it's actually got a Nike Plus logo on it, so this is going to be a custom LED driver. There's an inductor next to it. It's probably got a buck regulator, because obviously with a LED display it takes a lot of power, so you want to maximise the efficiency. So this is probably going to be regulating the LED voltage to precisely the right voltage to maximise the power efficiency of the display. So obviously that's really a major part of this device. So that looks like the only custom part on this unit. And here we've got the main processor. This is an SGS Thompson STM32 ARM Cortex M3, and again it's got a crystal there, and again we see this BGA underfill glue gunk all over it. A few test points here, and I'm guessing this is probably power management, battery charge control. We've got the other terminals for the other two batteries here, and just a few some 3-terminal components, are probably FETs and some other little chippery here, but just looking at the thickness of these tracks, I'd imagine this is to do with power. And up here, this goes up to the USB interface. You can see these two balance length curved tracks going to the USB connector up here. Not much of interest on the back side of this PCB, but you can see it looks like it's probably 6-layer. You've got the inner plane and then there's 2 layers of tracks on this side. One thing to notice on this, one common design feature on flex boards is they use these curvy tracks. The reason for that is to stop stress concentrations at bends, so when you bend it, you want it to all bend nicely the same way rather than putting any stress on any particular track. If you're doing flex, there's actually a whole bunch of design rules that you can get from your manufacturer to tell you sort of bend radiuses and that sort of thing. That's the little side bit with the red, green and yellow LEDs. There's the other battery terminals. Right, the power consumption is about 23 milliamps. That works out about an average 400 microamps per LED, so obviously high efficiency LEDs run as low as they can be run to give decent brightness. Just try adjusting the supply voltage up 3.6 up to 4 volts. It doesn't really make a lot of difference, so there probably isn't a switch mode regulator in there controlling the LED brightness. Although the LED brightness doesn't appear to be changing, so I go from say 3.6 to 4.2, there's no change in brightness on the LEDs. So I think it's just a fairly simple constant current drive. Well, I'm not totally sure how it deals with these dual batteries. I've just hooked some current meters in series with both of them, but it only seems to be charging and discharging this one. That's on charge at the moment. If I pull that, it starts discharging, but this one doesn't seem to be doing anything at all. Now it could just be that there's a broken connection in the flex somewhere, or maybe it only starts discharging that one when the first one gets flat. Actually, we can try that if we just try disconnecting this first one. No, it just goes out, so I'm not sure. It could be there's some flex damage that's stopping that one doing anything, or it could even be the battery's damaged. Just take a quick look at the multiplex on this display. It just so happens I've got a camera that can record 1000 frames a second, so I just shot a little bit of video of the display so you can actually see the sequence that the displays are driven. As you can see, it's addressing a row at a time on the top section, and that's been translated into a number of sections on the bottom colour LEDs that you probably just fitted into the matrix, so that although they're arranged horizontally, they're actually addressed as if there are additional vertical rows on the main display. Well, I managed to update the firmware on this thing and just gone through all this Nike registration nonsense. One interesting thing, this does actually have grayscale control on the display as well, so it's giving this throbbing go thing while it's charging. The ambient light sensor also seems to have started working. If I just shine some light onto it, it gets really, really bright. And cover it up, get dim. Right, this thing's now it's not in its normal running mode, so it's just looking at the accelerometer data. It's about 180 microamps. Most of that's going to be the accelerometer, I'd imagine. You can press the button, show various status, for example, number of steps. So that's saying 78. If I pretend to have run around a little bit. They're saying, oh, still 78. Doesn't seem to think I've gone anywhere. Let's try it again. $83, yes, it thinks I've gone another 5 steps. And current draw, so it's about 20 milliamps on its minimum brightness, but if I give it some bright light, 56 milliamps. That is really 88. Wow. This thing just cycles through a few standard displays. You've got your fuel, calories, steps and time, so it'll actually act like a watch. So if you leave it on that mode, whenever you press the button it'll tell you the time, which I suppose might appeal to people that like funky matrix LED watches. So interesting little bit of tech there, lots of super tiny components. There's on the flex. I mean, this is basically just a pedometer, just sort of designed to appeal to the luxury high-end Mac type people, but I think these guys are missing a trick. All this lovely high-techness in here, but it's covered in this black silicone stuff. Now if these people actually want to appeal to the techies, make the thing in clear silicone so this stuff's all on display. How much cooler would that be, huh? Well, I suspected these battery covers might be magnesium because they're very light, but they feel a lot harder than aluminium. So let's investigate. I've cut a little sliver off one here. Yeah, I think that's probably magnesium. Well, that was fun. Let's try the rest of it. Looks like it sort of forms a skin that stops the oxygen getting to it. Cool. And before people start saying in the comments that it's a bad idea to make battery holders out of magnesium, I don't think there's any realistic chance of even the worst lithium battery incident producing anything like enough heat to ignite the thickness of metal that was used on there, so I don't think there's really any concerns on that front. Right, just for fun, let's just see if this battery can actually do anything nasty if it gets abused. Just going to try shorting it out, courtesy of the good old unfused 10 amp range on an old Fluke meter. It looks like it's fairly well charged, 4 volts or so. 4 amps briefly, down to an amp. Not getting 30 or 40 degrees. I think a small cell like this has probably got enough internal resistance that it will probably self-limit. 57 degrees. I think a lot of the reason for that metal casing was really mechanical protection as much as anything else. Just to stop the battery getting damaged. Just keeping it as rigid as possible. 66. Still putting a decent amount of current out. I can smell something now. 90. 95. Now, oh, it's starting to bulge a little bit as well. It's definitely smell of something a bit warm. Looks like there's a little bit of a blister forming. Yeah, it's down about 65 degrees now. It's obviously done all its energy. It's only a 75 milliamp hour thing, so there's a limit to how much energy is going to be stored in there. Oh well, no fire, never mind.